Unit 6 Circles by Patrick, Julia, and Justin.
Introduction page. There is a chord, which are the endpoints on each circle. There is a secant, which means that the endpoints are out of the circle. There is a tangent, which means that it never goes into the circle. The diameter goes from one end of the circle to the opposite end in a straight line. The radius is half of the diameter.
Types of angles of a circle. There's inscribed angles, which is where the vertex is on the center, like right here. There are central angles, where the vertex is on the center of the circle, like these pictures. There's interior angles, where the vertex is anywhere inside the circle, like right there. And there's exterior angles, where the vertex is anywhere outside the circle, like right there. There are multiple rules for these circles. So if you look over here, and you want to try and find the measure of angle 1, you look at the arc CD plus the arc AB, and then when you divide that by 2, you get the measure of angle 1. If you want to find the measure of angle 2, you do arc BC plus arc AD divided by 2 equals the angle of measure 2. For just a key note, measure of angle 1 will equal measure of angle 3, and measure of angle 2 will equal measure of angle 4. Now the next circle, if you look at the measure of angle ABC, that's right there. If you take half of the arc AC, you'll get the measure of angle ABC. Now if you look over here, where the vertex is on the center of the circle, if you look at the measure of angle ABC, which is right there by B, it equals the arc of AC. Over here it equals half. When the vertex is on the center, it equals the arc. That's the last circle. Measure of angle 1 equals the arc BC minus the arc AD divided by 2, and you'll get the measure of angle 1. So here are some examples. You look at the circle, and you have x on the center angle. When you add 5 plus 7, you have 12, and divide 12 by 2, and that equals x. So down here, when you have 12 over 2 equals x, if you want to multiply the 2 over, you can have 12 equals 2x, and then x equals 6. Back up here, you have x right there, and you have 8 as the chord of AC. So to find this, you divide 8 by 2, which equals x, because this angle equals half of the opposite chord. Now over here in this circle, you have 12 as the chord of AC, or the arc of AC, and x is the angle. And when the angle is on the vertex, it equals the arc. So no work there, x equals 12. Now here, when the angle is outside of the circle, like angles measure 1, you do the opposite arc, which is 20, minus the closest arc, which is 4. So when you have 20 minus 4, then you divide it by 2, and that'll get you measure of angle 1.
This is properties of segments with circles. For two tangents intersecting outside of the circle, you will do half of the major arc minus the minor arc. So in this case, it will be half of 260 minus 100, which will give you half of 160. When you multiply 160 and 1 over 2, gives you 80, and that is the answer. For one tangent and one secant intersecting outside of the circle, you will do line A and E squared times E and B times EB plus BC, because that will give you the entire line. And so when we plug it into the equation, then you simplify. So then you do 10 plus 20, that equals 30. And then you try to get rid of the square. So then you do the square root. And then you get x equals around 17.32.
2 chords and 2 secants. So the equation is one side times the other is equal to this side and the other side. So 5 times 12 is equal to 15 times x. Simplify that. 60 equals 15x. And do 60 divided by 15, you're left with x equals 4. Now for the other side, you do part 5 times whole 5 plus 11, which is 16, and then 4 times 4 plus x. If you simplify that, you're left with 5 times 16 equals 4 times 4 plus x. And you can just distribute, you're left with 80 equals 16 plus 4x. Subtract 16 from each side, 64 equals 4x. Divide by 4, and then you're left with x equals 16. Radius and tangent intersecting. So the rule, both radii are equal, and both tangents are equal. When they meet, it forms a right angle. Now, if you're left with a shape around a circle, 2 adjacent sides are equal. So side AH is equal to side AB. So they are both 12. GH and side FG are both equal, and so they are each 3 because the whole line AG is 15, and 15 minus 12 is 3. And now, line CB is equal with line DC, and since line BC is 2, line DC is also 2. And since you're given that line ED area, so the formula for arc length is 2 pi r times angle over 360. So to find the arc of x, you do 2 times pi times 12, which is the radius, times the given angle 120 over 360. If you simplify that, you're left with pi times 24 times 1/3. And 24 times 1/3 is 8. So the arc of x is equal to 8 pi. Now sector area. To find the shaded region, the formula is pi r squared times angle over 360. So with the radius 12 and the given angle 120, your equation is now pi times 12 squared times 120 over 360. And if you square 12 and simplify 120 over 360, you're left with pi times 144 times 1/3, which gives you 48 pi centimeters squared as the answer. Checklist. Be able to solve equations with 2 chords or 2 secants. Know how to solve for arc length and sector area. Know all the types of angles in a circle and how to solve them. Solve problems with radius and tangent intersecting. Be able to solve problems with 2 tangents and problems with a secant and a tangent. And know the rules of angles in a circle.
Pause the video and try these. When you're ready, here are the answers. Now pause the video to try these. You have this page and this page. When you're ready, here are the answers.